How are you, my friends? This video is presenting 13 additional solved questions related to rational expressions, how to simplify them. Now, the rational expressions, if you need to see the lectures, please you can go to algebra lectures number 13, 14, and 15 in the playlist called Algebra Course Lectures. Let's start the questions. Find the domain. If you need to know the definition of the domain and other stuff, you can go to the lectures. Find the domain of the rational expressions. We have 3 examples. So the first one, x cannot be 0, x cannot be 2 here. So we say all real numbers except 0 and 2. Easy. Just look at the denominators here. 2k plus 7 cannot be 0. So if you take 7 on the other side, k cannot be minus 7 over 2. This is the only number that will make this one 0. So we say the domain, all the values of the x that we can replace in the expression. So it's r except minus 7 over 2. This is a little difficult here, number 3. Square root of 5 minus x. If I need the domain, I have to make sure that all the radicand must be positive. All the numbers here under the radical should be positive. So we say 5 minus x greater than or equal to 0. We make this condition. So if I take 5 on the other side, there is a minus. I have to multiply with the minus and change the sign. So x will be less than or equal to 5. There's equal here, so I put closed. So now the domain, all the numbers starting from minus infinity until 5 closed. Now here we need to simplify or write the expression in lowest terms. So you can see here, something divided by something times something. What do we do here? We start from left to right by order of operations. We do this. Division here, we change it into multiplication. So part number 1 is this. We change this division into multiplication and we multiply by the reciprocal. So 1 minus t becomes in the numerator, this one in the denominator, and then we start factoring. See, the whole idea here is to factor. So we use this formula here, division, C, multiplication by the reciprocal. Now let's factor. Take a common factor t here, t squared minus 9, the first one. Down we take 10 common factor, 10 squared minus 1. Here we take 1 minus t, we leave it. Here we take 2t as a common factor. 20 we leave it, t minus 3 we leave it. Then we go and continue factoring. T squared minus 9, that's difference between two squares. Remember, we have to change, we have to change everything into multiplication and brackets in simple form. T minus 1, t plus 1, then we start canceling. To cancel, you can choose the same color here. See, this is blue, you cancel t and t. T minus 3, there is a t minus 3, the whole bracket, you cancel it. And there is a green t minus 1, t minus 1, t plus 3, t plus 3. What's left? There is a minus. Be careful here. There is a 20. And there is a 10 times 2 times t plus 1. So 20 t plus 1. Cancel the 20 again, just not to make any noise there. So this will be minus 1 over t plus 1, the final answer. Now you can try the second one. Same idea, maybe more difficult. You have to factor here. Remember, this is the division. Leave this multiplication. Use RDF here. Now let's see in the solution here. We go first to the division and we use RDF. We change division into multiplication. And here we multiply by the reciprocal of the given. Easy now. Let's go and factor, please. So here we take a common factor. So that's a squared minus b squared. Down we take 2a outside. So a squared minus ab. Remember, there's a 2 common. And then b squared, we leave it there. We leave this one, we leave this one. A cubed plus B cubed, we have to factor now. There's a formula here. We'll factor it in the next slide. Remember something very important. We have to simplify the question. So here, given in the question, A plus B squared, never, never, never expand. Because we need to factor this, factor this, factor this, cancel, simplify. So this one is a little trick for some students. Do not expand it. Okay, just leave it, leave it. Now, a squared minus b squared, a minus b, a plus b, difference of two squares, we know that. Now this one, the cube, you see, a cubed plus b cubed. I showed you the formula in the previous slide. A plus b, a squared minus ab, there is no 2 here. And this one, there's another trick here. We cannot factor this because there is no number inside here. So just leave it. See this one, in the cube, we have small bracket, a plus b, big bracket. A squared minus ab plus b squared. This will be cancelled with that one. See the big cancellation. Now, a plus b, that's squared, and we have here squared ready. So this green one will cancel. What else? A cancels with the a. You see the a. We have a minus b. There is a 2 there. 12a squared, 36a squared. A squared will be cancelled. What else? 12 divided by 2, 6, and we have here 36. So the final answer, if you try it, you check it, a minus b over 6. All right, let's see, question number 3. Perform the addition. This is easy. Why easy? By looking. Why it's easy? Now we have a fraction minus a fraction. Here we have a fraction plus a fraction. Why it's easy? We see the same denominator. M minus 3, that's the same. T squared minus 1, T squared minus 1, same. Now, after a few minutes, you will see more difficult examples or questions where we have the denominators are not the same. So the first one is easy. Check the denominators first, same denominator, perform directly. So I can write 2m squared minus 4m. Remember here, this minus, you change the signs like this. You have to change the signs. Minus m, minus 3. You can go directly there. And then we add like terms, 2m squared minus 5m. Factor it. See, factor it. You have 2 ways. You can trial and error. You can factor directly. Or you can use slide and divide. Go to lecture number 11. Algebra lecture number 11. So this one, we cancel m minus 3. So 2m plus 1 is the final answer. You can try this one, please, number B. So easy, same denominator. If you tried, let's go directly to see the solution. We write, see, same denominator. We just add t squared plus 2t minus 3, factor as usual, t plus 3, t minus 1. And this one, t squared minus 1, difference between 2 squares. I would say again, when you're adding fractions, you just write the denominator 1 time, but you have to leave it. Factor it, cancel t minus 1, the final answer t plus 3 over t plus 1. Now, here, little more difficult questions. Let's find only the LCD of these given fractions. We will not add or subtract. Later we'll do that, but now we have to find the LCD, 7 over 4m squared, 5 over this, 1 over 10m cubed. Now I have explained the LCD in details in the lectures. You can see that maybe lecture 13, 14. To find the LCD, we need to factor each denominator first. So easily, whatever the question is, simple, medium, or difficult, take this one and factor it. Make it prime numbers. 4, make it 2 squared. This is m squared, leave it. This one, 2, take 2m common, and then inside m minus 3. 10, make it 2 times 5m cubed. Never, never, never multiply all the denominators as usually students can do, unless we have prime numbers and there is no power, there is no common. Now, what is LCD? LCD is the product of prime factors raised to highest power. So I take number by number, 2 squared, 2, 2. The highest power, 2 squared. I take 5. See, I have only 5, so I take it. If I have 5 and 5 power 4, I take 5 power 4. Now m squared, m cubed. See, m is a number, like prime number, m cubed, m and m squared. I take m cubed. M minus 3 is another number. No connection. M minus 3 is a number, m is a number. So define and multiply here, 2 squared, 20 m cubed, m minus 3, this is the LCD. If you need to add or subtract, you have to use this LCD. Now here, let's add and subtract, and we have different. You see, t minus 2, 2 minus t. This is different from this. This is different, different, different. Very nice question number 5. Let's go one by one. First one is usually simple. Well, you can try anyone if you like. You can pause the video, try it, and then you can compare with my solution. Now we know this is a little similar. T minus 2, 2 minus t. So we remember the important rule, 2 minus t, I can change it. If I take minus out, it will be minus bracket t minus 2. See, multiply here minus t minus minus 2 plus 2. So instead of this, see this one here, this is in the given. I change it to this. Then I take this minus up. So it becomes t minus 5, and now we have the same denominator. So we can say here, the LCD is t minus 2. Now if you have t minus 2, t plus 2, remember, that's different. T minus 2, t plus 2, you can write it down, then you have to multiply the two factors, t minus 2, t plus 2. So now here, same LCD, see, t minus t, you write it time, t minus 5, that's the answer here. T minus 5 over t minus 2. I think the second one is more difficult. I advise you to try B and C before you see the solution if you want to learn more. If you want to see the solution directly, we can go now. Let's see number B. Number B takes 2 slides. Now, this is not easy. 6a over a squared minus 2a plus 1. This one over a squared minus 1. We need to factor first in the denominator. This one is the formula. Perfect. You should know this one. Perfect squared, a minus 1 squared, a squared minus 1, a minus 1, a plus 1. Now I look at the LCD. The important part is the LCD, because these are fractions with different denominators. I remember the LCD. I take each prime number, a minus 1, with the highest power. So I take a minus 1 squared. A plus 1 alone, I take it, because that's the highest power. Now look at the question. This is the question here. I made the question longer, here bigger. 6a, leave everything in factored form. How can I change each one to be like the LCD? So the first term here, I have a minus 1 squared. So I should multiply by a plus 1 up and down to make it like the LCD. Now this one, 1 over a minus 1, a plus 1. I need a minus 1 to make it squared. See, the aim here is to make both denominators the same. Let's continue on the next slide. See, I made them now same denominator. So this will be 6a, a plus 1. See from here, 6a times a plus 1, and then a minus 1 here. Just expand like 6a squared, 6a, a minus 1. You can add these two like terms, 7a. Now leave the LCD. See the LCD, we have to leave it in factored form. Now sometimes we can factor this, 6a squared, 7a minus 1, but here we cannot factor it. If you can, factor it and simplify. Oh, B. Okay, maybe you have tried the B. Very nice B's. One slide, 2 over 3, b squared minus 1 over 4b, b minus 4 over 6b squared. The important part to find the LCD. Now, break all the numbers down because we need prime numbers. 3, leave it 3. B squared, leave it 4. 2 squared, 6, 2 times 3. So I look at the 2's here, 2 and 2 there, 2 squared. And the 4, 2 from the 6, I take 2 squared. I have 3 and 3, so in power I take 1, 3. I have b squared, b and b squared. I take b squared, the highest power. If I have b squared, b and b cubed, I take b cubed. So if you multiply all this, 12. So I have to make this one 12b squared. I have to make this one 12b squared. I have to make this one 12b squared. I put here very clear, detailed method. Now, maybe some of you will ask, which numbers I multiply up and down? To know easily, you can take the LCD in your mind, see 12b squared, divide by the old denominator, and then multiply up and down. So 12b squared divided by 3b squared, that's 4. You can take also again 12b squared in your mind, divide by 4b, you get 3b up and down. 12b squared divided by 6b squared, so that's 2 up and down. Now when you multiply, see now we have 12b squared, 12b squared, 12b squared, multiply the numerator, and then we add, we get 8 minus 3b plus 2b minus 8. So altogether becomes minus b. You cancel the b, minus 1 over 12b is the final answer for this question. Really nice, 5C. Now let's simplify complex fractions here. Really complicated maybe. 1 plus this over this, and this is negative powers. We have a fraction over another fraction. So let's simplify each one. Let's take the first one. You can try yourself, it's a good idea, to get, there's a fraction here, 1 fraction equals to this. I advise you to start down. So don't start here, start down. In the bottom here, fraction. 1 plus half, easy to add. Instead of this one, I put 2 over 2. So 1 plus half, 3 over 2, easy numbers. You can do that. See here, I started there. And this one, 2 over 2. So I add 2 plus 1, 3 over 2. You see this one. So I put 1 without colors, 1 with colors, without colors, colors, so that you can see the final, nice, easy answer, 8 over 5 is the whole complex fraction. Now, this one you have 3 over 2, so it becomes 2 over 3, because this is the reciprocal. You see 1 over 2 over 3. Now I take this one, and instead of this one, I have denominator 3, I say 3 over 3 plus 2 over 3. So that's 5 over 3. Then there is 1 here, I can say reciprocal. So 1 plus 3 over 5. This one, I can make it 5 over 5. I have the same denominator, then I add. So nice and straightforward. 8 over 5. Now I agree, number B is not easy. I can tell you the idea or trick or the hint. Take each negative power here, like this one, 1 over x cubed. This one, the power on the x only, leave y over x squared. And then this is a complex fraction. See, in the lectures, in the algebra lectures, I gave 2 methods. You can check, I think, lectures 13, 14 for the complex fractions, or 15 also, 13, 14, 15. All right, now the second one, 2 slides maybe. Yeah, I said here, 1 over x cubed. Remember the power negative 2 on the x only, so y over that. If you say 1 over yx squared, you lose the whole question. Now, let's find LCD for all fractions, which is x cubed, see x cubed, and then y squared, the highest power. So this is method number 2. There is also a playlist called How To do something. I put one video, one question about complex fraction, method 1, another one, complex fraction, method 2. You can check that. Different question, one question only. It will simplify, explain method number 1, method number 2 for complex fraction. So this is method number 2 actually. I take the LCD for all fractions, remember, all fractions, 1, 2, 3, 4, and 5. This is what we mean by all fractions in the question. Multiply up and down by this, and then try to simplify now. This times this distribution times that, this times this times this times this. You see on the next slide what will happen. See what will happen in magic, no fractions up and down. So we just multiply there and then simplify. Simplify, you have to factor. This is what? Perfect. Y squared, x squared, I can put here x squared, y squared, 2xy, just directly I write x plus y squared. I take common factor here, xy, and that's y squared minus x squared. This is the difference between two squares. So I can cancel 1 y plus x, and then the answer will be x plus y over xy bracket y minus x. I never multiply, leave the answer like this, better. Thank you for watching. If you like the video, you can subscribe and share with your friends. And I hope I can see you in another video with another topic. Thank you very much.